Hi, this lesson's talking about geometric series. So we just finished a lesson on arithmetic series, which arithmetic series was the sum of the terms of an arithmetic sequence. Well, geometric series is pretty much the same thing. It's the sum, but instead of an arithmetic, it's a geometric sequence. So the geometric series is the sum of the terms of a geometric sequence. And we can find this sum similarly how we found the sum of an arithmetic series. We're given a formula. So the sum S sub n of a finite geometric series a sub 1 plus a sub 1 times r plus a sub 1 times r squared onto a sub 1 times r to the nth minus 1, where r, the common ratio, is not 1, is this, where a sub 1 times 1 minus r to the nth all over 1 minus r. And then remember what these terms stand for. A sub 1 really means, it talks about the first term. So that's the first term. R is just the common ratio. And then n, if you remember, is the number of terms. So number of terms in the series. Now, in this tutorial we're going to be solving a few problems, and you're going to have to use this formula. So the way that I like to think about it is, if you write this formula, get that there. If you write this formula, notice we need the first term, we need the common ratio, and we need how many terms are in the series. And we're going to find ways of how to find all three of those terms when given 1, 2, or 3 of those. Alright, so let's look at the first problem. We're asked to find the sum of the series 3, 6, 12, 24, and that pattern continues all the way to 3072. So first we need to figure out, is this an arithmetic or a geometric series? If you look at it, notice that we have a common ratio. So 6 over 3 is going to be equal to the 12 over 6, which is also equal to 24 over 12. And this pattern continues, and so our common ratio is 2. So I'm going to go ahead and label that out to the side. So we know our ratio is 2. We know our first term is 3. And so now we want to find the sum of this sequence. So we're going to have S sub n is equal to a sub 1 times 1 minus r to the nth over 1 minus r. Now I like to go ahead and write out the formula for this sum always, and then I think about what I have and what I need. So I have the a sub 1, I have the common ratio, but I don't have the number of terms. So I need to find my n. So the way I do that is to find the number of terms that are in the series to get from 3 all the way to 3072 is use the explicit formula. Okay, so again, an explicit formula for geometric series, we write a sub n is equal to the first term times the common ratio to the power of n minus 1. So now, let's look at this. We have the first term and we have the common ratio, and then we have a sub n. Now let's think of this as the last term. Okay? So let's see how many terms there are to get from 3 to 3072. So the 3072 is going to be my a sub n. That's the value of the last term that we're trying to find. So 3072 is equal to my a sub 1. Well, that's the first term, is 3, times my common ratio, which we know is to be 2, to the power of n minus 1. So now if you look at this, we have an equation with only one variable. We have n, but it's in the exponent. So remember, to solve for variables that are in the exponent of a term, we have to use logarithms. But before I do that, I need to get rid of that 3 out in front of the 2. So I'm going to divide both sides by 3. and I'm going to get 1024. And then this side is going to be 2 to the power of n minus 1. Now, I have this term all by itself, and I have to get this variable out of the exponent. So I'm going to use the logarithm. Remember the properties of the log. So I take the log of both sides, and remember that this property lets me take the exponent and move it out to the front. So now I'm going to have log of 1024 is equal to log of 2, and what I'm going to do with that exponent is I'm going to take it to the front, and now it's just going to be multiplied to the log of 2. So now I'm going to solve this equation for n. I'm going to go ahead and do this rather quickly. I'm going to skip a few steps, but remember here to get through here, to solve for n, I'm going to have log of 1024. And since I'm multiplying by the log of 2, I'm going to divide by log of 2 to both sides. So log of 2. And then I would be left with n minus 1. So to get rid of this minus 1, I'd have to add 1. Now, if you do this in your calculator, log of 1024 divided by log of 2, you'd get 10 plus 1, which is equal to 11. So that means that my n, it takes 11 terms to get from 3 to 3072. So I can go ahead and place that 11 up here for it. Now I can come back. Now that I have all three of these variables, I can plug those into my sum formula. So let's go ahead and do that out to the side here. So I'm going to have s, and it's not sub n now, I know it's 11, so s sub 11 is equal to a sub 1, which is 3, times 1 minus the common ratio, 2 to the power of 11, all over 1 minus 2. So now we can use our calculators to help solve this problem. So we're going to have 3 times 1 minus 2 to the 11th. And I want to put that into my calculator exactly how it shows. And so when I put that in the calculator, the numerator comes out to be negative 6,141. And now I need to solve for the denominator. 1 minus 2 would give me negative 1. And when I divide something by negative 1, all that does is change the sign. So I get 6,141. Now make sure that you guys can do that in your calculator, because it's going to be silly to do all this work and be able to do it, but then you plug it into the calculator incorrectly and you get the problem wrong. So it'd be silly just to miss a few points on the problem just because you're not able to put it in the calculator correctly. So make sure that you can do this in your calculator. So for problem 2, there's a story in the book that I would like for you to read before you watch this video. So pause the video, read the story that's on the bottom of page 596 in your Algebra 2 book. And then once you're done reading that soldier's story, it's the soldier's reasonable request. Once you get done reading that story, then press play and I'll go through problem 2 with you. Okay, so now that you've read the story, the soldier asked the king for a chessboard and we know that chessboards now have 64 squares on them. It's an 8 by 8. And he asked the king for a chessboard with 1 kernel in the first square, 2 kernels in the next, 4 in the next, 8, then 16, 32, and so on. All the way up until the last box or square. So there's the 64. So it continue all the way up to a sub 64, or the 64th term. Now, is this reasonable? Well, the king agreed to it because he didn't think that'd be that many. Well, it started off with 1 kernel, a kernel of wheat. Well, one plant produces more than 1 kernel, so you're starting off very low. How many kernels of wheat will he produce, or will he get from that? So, this is a summation formula again. So let's go ahead and write down the formula. So S sub n is equal to a sub 1 times 1 minus r to the nth over 1 minus r. Now if you look at this, let's try to find what our ratio is. If we look at it, it looks like we're multiplying each term by 2. So 1 times 2 to get 2, 2 times 2 to get 4, 4 times 2 to get 8. So I'm multiplying by 2 each time. So there's my common ratio. So I'm going to put R as 2. My first term is 1. And N, the number of terms. Well, I know there's 64 terms in here. So I have everything I need to solve the sum of this series. So S of 64, the sum of 64 terms, is equal to 1 times 1 minus the ratio 2 to the power of 64, all over 1 minus 2. Now, you should see that 2 to the power of 64, this might be a big number. So let's go ahead and work that out in your calculators and see what you get. Once you do that, you should get a number that's close to, and I'm just going to round off to the first decimal that we get, 1.8 e to the 19th, which is times 10 to the 19th power. Oh, that's 9. Meant 19. And I just hit the back button and it screwed everything up. Alright, stay with me. So 1.8 times 10 to the 19th power. I don't know why I tried to mess it up again. Alright, now, so this is the scientific notation. Let's go ahead and write it out like a normal decimal number. And so if we were to do that, we would have 18 zeros. So let's do that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we have a huge number of kernels of wheat. Now, this is kind of crazy, because we started off just giving 1 kernel, then 2 kernels, then 4, and it got up to be this huge number. Now, one thing about geometric series is sometimes they diverge really fast, which means the next number in the sequence or in series is going to increase greatly. And that's one of the properties of exponents. Sometimes, especially if this ratio is bigger, quite a bit bigger than 1, this diverges really big. So it starts getting to be huge numbers like this. So just a quick fact, in a recent year, the United States total output was 2.1 billion bushels. And so 2.1 billion, and let's see real quick, a bushel of wheat contains about 1 million kernels. So if we did, had 2.1 billion bushels times a million kernels, we'd get 2.1 times 10 to the 15th. So that would be 14 zeros. There's 6, 9, 12, 14, and then there's that number. So the bottom number, this is the total amount of kernels of wheat that the U.S. produced in 1 year. This is the number of kernels that the one soldier requested. Now, he kind of tricked the king using this summation notation and geometric sequences and series, and the king agreed to do that. Well, notice that it really quickly added up. So if he was to sell all those kernels of wheat, because there's a lot of food that people make from wheat, this guy would be a rich man. Just knowing math. Good stuff. Alright, the next thing we're going to learn about geometric series is infinite geometric series. Now, an infinite geometric series, you notice the word infinite. Well, infinity keeps going on and on and on forever. So an infinite geometric series is a series with an infinite amount of terms. It will never stop. But we can still find the sum of certain infinite geometric series. So it says an infinite geometric series with first term a sub 1 and common ratio with the absolute value of r less than 1, so this is important, the r, the common ratio, if it is less than 1, it has a sum of s is equal to the first term divided by 1 minus r. Okay? Now, if the ratio, the common ratio, or the absolute value of the common ratio is greater than or equal to 1, then it does not have a sum. Now we're going to look at this. So if we have a series with a common ratio of, let's say 2, and we start out at any number, it doesn't matter whatever number, let's say we start off at 1. Well, the ratio of 2, we multiply by each term by 2 to get the next. So 1 times 2 is 2, and we get 4, we get 8, 16. This is just like the problem 2, the soldier's story. Now each term after the next keeps on getting bigger. And it would continue to get bigger. And it would never stop getting bigger, so it would keep increasing on to infinity. And when this happens, we say that this infinite series diverges. Well, diverge means to grow apart, so it diverges. Okay? Now let's look at one if the ratio is less than 1. So let's say 1/2. Okay? So when we look at this, let's start off with 1 again. But now when we multiply by 1/2, the numbers get smaller. So we'd add 1/2. Then we'd add a 4th. Then we'd add 1/8. And it would continue 1/16, 1/32, 1/64, 1/128, 1 divided by 256, and we could keep going. 1 divided by 512. And now notice what's happening to the terms as we keep going on and on forever. Well, we are getting smaller and smaller and smaller. Now, these won't necessarily ever get close, well, won't technically become 0, but they will become so infinitely close to 0 that after a while we will not be able to tell a difference. And we would be able to sum everything up and we would get this number. And if you put all of these into the calculator and you add them up, we're going to get a number that's really close to 2. So let's go ahead and put those into your calculator right now. It'll only take a minute. So just go ahead and put those into the calculator and see what you get. And so if you did that, you would get 1.9980, and you'd get something else. Now if we kept adding, the next terms would be something really small. So it would be 1 over 1024, 1 over 2048, 1 over 4096, 1 over 8192. And these numbers right here are so close to 0 that it's basically like we're adding 0 to this number, and this number is going to barely increase and increase, and it will never get past 2. So we'd call that's an asymptote. So this series would diverge, I'm sorry, not diverge, but converge to 2. So this sum of this series would be 2. Now, if you can't see that, that's why we have that formula up here. So let's use that formula and see if we get the same number. So it would be a sub 1 over 1 minus r. Well, the first term is 1. And we're going to divide it by 1 minus the ratio, which is 1/2. Okay, so we got 1 over, and 1 minus 1/2 is 1/2. And when we divide by 1/2, it's like multiplying by the reciprocal. So it'd be take the numerator times the reciprocal of 1/2, which is 2 over 1, or 2, which gives me 2. So the sum of that infinite series would be 2. Well, that's it for this video. Thanks for watching. Have a great day. Hopefully you learned something. Bye.